Hey class, this is Mrs. Lyons. Time for some chemistry. Today we are going to work through several examples of bond enthalpy calculations. Okay, so one thing that you should have handy while we're doing this, I have one pulled up on my computer screen, but you'll need your bond enthalpy table that gives you the values. Okay. We're going to do, it looks like, 4 examples of calculating bond enthalpy. Okay. And remember what we've got to do is we have to, so here's our dividing. We have our reactants, we have our products. Okay. We need to calculate the bond enthalpy. And to do that, we are going to take the energy that it takes to break bonds, and we're going to subtract the energy it takes to make bonds. And that's going to give us our change in enthalpy. All right. So first thing and most important thing to do is to look at our Lewis structures and count the number of bonds on each side of the equation. So on this side, I have one HH bond, so one hydrogen-hydrogen. I have carbon-hydrogen bonds, so I have 1, 2, 3, 4 carbon-hydrogen bonds. And here's one that sometimes gets forgotten for some reason. We have a carbon-carbon double bond that we cannot forget. We've got one carbon-carbon double bond. Okay, so now if I look at my table of average bond energies, all right, I see that hydrogen-hydrogen is a 436 kilojoules per mole. Carbon-hydrogen is 413 kilojoules per mole. And that carbon-carbon double bond is 614 kilojoules per mole. All right. So we do need to multiply that carbon-hydrogen value by 4. Okay, so we've got 4 carbon-hydrogen. So 4 times 413 is 1652. And then I'm going to add that to 436 plus 614. And I get a total of 2,702. 2,702 kilojoules per mole. Okay, now we need to look at our product. And over here, if you count, we have 1, 2, 3, 4, 5. We have 6 carbon-hydrogen bonds. And that one, again, in the middle, sometimes I skip this myself. That one, it's a carbon-carbon single bond. Okay, so if I look at my bond enthalpy, carbon-hydrogen is 413. So I'm going to write this down here. So 6 times 413. And then 1 carbon-carbon, and carbon-carbon is 348. Okay, so 6 times 413. Whoops, that didn't work. 6 times 413 is 2478 plus 348 is 2826 kilojoules per mole. So if you look, what I'm going to do, I'm going to take my 2702 and I'm going to subtract 2826, and that's going to give me 2702 minus 2826 is minus 124 kilojoules per mole. Okay, so we just calculated this, and this reaction, because this is negative, this makes this an exothermic reaction. Ready to do another example? I hope the answer is yes. Practice makes perfect, you know. All right, so this reaction, okay, here's our dividing line. All right, if we look, we have two H2O2s, those are peroxides. And if you look at the bonds, we have hydrogen-oxygen bonds and we have oxygen-oxygen bonds. So we have hydrogen-oxygen, we have 1, 2, 3, 4. We might as well look. Hydrogen-oxygen, the value is 463. And then we have 1, 2 oxygen-oxygen single bonds. And the value in my table for that is 146. So let's see, I'm going to take 4 times 463. That gives me, there's not enough room to write here. I apologize. 1852. And then 2 times 146 is 292. If we add those together, whoops, we get 2,144 kilojoules per mole. Okay, that's our breaking. Now, on the other side of our reaction, we have our bonds that we make. Okay, now notice it's kind of interesting. We are making 4 hydrogen-oxygen double bonds. Or, excuse me, hydrogen-oxygen single bonds. Okay, which is what we had over here. Okay, but we're gonna do the math just to practice. Okay, so we have 4 of those, so 4 times 463, and then we have this oxygen-oxygen double bond. And if I look at my table, the bond enthalpy is 495. All right, so I've got 4 times 463 is 1852. And then we've got 1 times 495. So if I add those together, I get 2,347 kilojoules. So I'm going to do breaking minus making, 2144 minus 2347. And I get a negative 203 kilojoules per mole, which means this is also an exothermic reaction. I think if we actually look at all of the calculations that we do, a majority of the things we do are going to be exothermic. We will occasionally come up on an endothermic example, but a lot of things that we can study with our level of knowledge and ability are going to be exothermic. All right, so let's do example number 3. We're booking right through these, huh? All right, so I always like to draw this line down so I know where my reactants are and where my products are. Okay, so in the reactants here, I have 1 CH4, 3 Cl2s. Okay, so I have carbon-hydrogen bonds. I have 1, 2, 3, 4 of them. So I'm going to try to make my space. Carbon-hydrogen bonds, so 4 times, what's carbon-hydrogen? 413. Okay, and then I have chlorine-chlorine bonds, and I have 1, 2, 3 chlorine-chlorine bonds. So 3 times, let's see, what is chlorine-chlorine? 242. Okay, so 4 times 413 is 1652. And then 3 times 242 is 726. I'm going to add those together, and I will get 2378 kilojoules per mole. All right, those are my breaking bonds. Now I'm going to make bonds. What am I going to make? I am going to make, oh, check it out, carbon. I have one carbon hydrogen. Okay. So one carbon hydrogen, which carbon hydrogen is 413. I have 1, 2, 3 carbon chlorines. So if I look at my table, carbon chlorine bond is 242. And then I have 1, 2, 3 hydrogen chlorine bonds. And the total for that is 431. So let's do some math here. So we've got 1 times 413. So we've got 413 plus 3 times 242, which is 726. And 3 times 431, which is 1293. So let's add those together. And we get 2,432. All right, so we're going to take 2,378 minus 2,432. And we get a total of, let me write this a little more neatly, 2378 minus 2432 is equal to 54. Is that right? Yep, negative 54 kilojoules per mole. Okay, again, an exothermic reaction. All right, we're entering the home stretch. One more example here for this video. Okay, let's see. Here's my dividing line. I have on this side, I have a hydrogen carbon bond. And I should get to know this number, right? We keep using it, 413. Then I have a carbon-nitrogen triple bond. So you want to make sure on the table that you're looking for the triple bond. We have one of those, and the energy is 891 kilojoules. It's much harder to break a triple bond than it is a single bond. And then over here we have 2 hydrogen-hydrogen bonds. And those were 436. So let's see if we can do the math here. 413 plus 891 plus 2 times 436, 872. Add those all to 413 plus 891 plus 872, 2,176. Okay, that's the energy to break those bonds. Now we got to look over here to see what bonds are being formed. Okay, so I see that I have carbon hydrogen. I have 1, 2, 3 carbon hydrogen bonds. So 3 times 413. Then I have a carbon nitrogen single bond. What is the value of that? Carbon nitrogen single. I've got one of those, and that is 293. And then I've got 1, 2 nitrogen hydrogen bonds. 2 of them. And nitrogen hydrogen is 391 kilojoules. All right, so let's see. 3 times 413, 1239, plus 293, plus 2 times 391, 782. So we're going to add those all together, and we get 2,314. I'm going to check my math just in case my fingers got klutzy. 1239 plus 293 plus 782. 2314. Okay, so here's what we've got. We've got 2,176 for our bonds breaking, and we are going to subtract 2,314 for our bonds making, and I added them. 2176 minus 2314. We get negative 138 kilojoules per mole. Again, an exothermic reaction. All right, so that's bond enthalpy and some calculations. It's not terribly hard. It's another one of those things that, guess what? Practice makes perfect. So practice, practice, practice. I hope you are doing well. I will see you in class.